Right, electrochemistry is the branch of chemistry electrochemistry is a branch of chemistry which deals with interconversion of electrical energy and chemical energy. Electrical energy and chemical energy. Okay, this is how we define electrochemistry in general. So electrochemistry is a branch of chemistry which deals with interconversion of electrical energy and chemical energy. Okay, by passing current you can you can make some chemical reaction to occur, or by doing some by making some chemical reaction to takes place, you can generate electricity. Okay, so you can convert chemical energy into electrical energy. You can also convert electrical energy into chemical energy. Right? So this branch of science or chemistry discuss mainly about this interconversion. Okay. Now, students, you know very well, we based on the electrical conductivity of material, we classify material into different type. Okay, so materials, right, based on conductivity, electrical conductivity, based on electrical conductivity. Okay, we classify materials into different types. What are the different types? You know very well, conductors, semiconductors, then insulators. What are conductors? Conductors are materials which allow free or easy passage of charges. Okay, positive or negative charges. Okay, if positive charge or negative charge pass through a material easily, okay, without much obstructions, we call those materials as conductors. What are insulators? Insulators are material in which the passage of electric charge is difficult. Okay, so we can say that insulators are very poor conductors. And in between we have another type of material called semiconductors. Okay, they allow a partial passage of charges. Okay, depending upon the external effect. Okay, they show some partial conductance, right? But under electrochemistry we are going to focus mainly on conductors. Students, observe carefully. Conductors are materials which allow free passage of electric charges, positive charge or negative charge. Okay, we divide this conductor again into two, right? One is metallic conductor, and the other one is electrolytic conductors. Okay, what is a metallic conductor and what is an electrolytic conductor? Metallic conductors, yes, metals are examples for metallic conductors, in which electrons, also called the free electrons, right? These electrons, also called charge carriers, they move freely when you supply electricity through a metal. So metals are good conductors of electricity, right? In metals, the conduction is due to free electrons. Okay, metals have free electrons. So when you pass current through metal, these free electrons will carry the charge, okay, or carry the current and move from one end to another end. Is this clear? So metallic conductors are good conductors, and the conduction in metallic conductor is due to free electrons. Okay, keep that in mind. Whereas we have another conductor called electrolytic conductor. Electrolytic conductors are materials in which conduction occurs due to the movement of ions. Okay, due to the movement of ions. Ions will migrate from one corner to the another corner of the material. Okay, so because of this movement, the electrolyte conduct current. Okay, so free electrons conduct current in metallic conductors. In electrolytic conductors, the conduction is due to ions. Students, observe carefully. We are going to focus mainly on the electrolytic conductors. Okay, we are going to focus on this part. Okay, yeah, so under electrochemistry, we are going to focus mainly on electrolytic conductor. But before going to see that, let me give some information about metallic conductors. Okay, then how this electrolytic conductor differ from metallic conductor, that we'll discuss, so that you'll get some clarity over these two conductors. Okay, I repeat again, conductors are materials which allow free passage of electric charges. That means they are good conductors. Actually, they allow maximum conductance, right, or maximum current to pass through. Okay, and in conductors we have two types, metallic conductor and electrolytic conductor. In metallic conductor, the conduction, electrical conduction, is due to the movement of free electrons. Okay, movement of free electrons, or that's why metallic conductors are also called as electronic conductors. Electronic. Because electrons are responsible for conductance. So metallic conductors are also called electronic conductors. Okay, whereas in the other hand, we have another conductor called electrolytic conductor. In electrolytic conductor, the conduction is due to the migration of ions. Okay, and under electrochemistry, we are going to focus on electrolytic conductors. Okay, so let me move on to electrolytic conductor, but before that I will make some difference between these two. Is this clear, student? Any doubt up to this? Right. So in metallic conductor, as I told you before, the conduction is due to movement of electron. Okay, in metallic conductor. In metallic conductor, the electrical conduction right, is due to movement or migration, right? Let me use the word movement of free electrons that is available in the metal. Okay, since electrons are moving, this conductor is also called electronic conductor. Right, now students, observe carefully. When electrons, suppose I'll take a metal, I'll connect one terminal or one end to the negative terminal of the battery and another terminal to the positive terminal of the battery. Just for understanding purpose, I am giving like this. When you switch on the battery, what will happen? Electrons will enter. This is negative terminal. Small line indicate negative terminal and the larger one indicate positive terminal. From negative terminal, electrons are negative terminal will provide electron. So electrons will enter here. From the battery, electrons will enter here. What will happen? These electrons pushes the free electrons present in the metal to move to the other side. So there are free electrons available. So when one electron enters here, one electron starts to move. Just imagine like that. Okay. So what will happen? These electrons will move from one end to the other end. Because of that, conduction happens. Now what is important here is, see, in metal we have the positive ions. That is you know very well, when many metal atom combine together and form a metal, what will happen? Each metal atom will lose 1 or 2 electron depending upon the valency. Students, observe carefully. When metals are formed, how metals are formed? Due to the combination of many metal atom, right? When many metal atoms comes closer and combine together and form a metal, what will happen? Each metal atom lose one or more electrons. Okay, and when the atom lose electron, that atom become ion. Okay, so in metals we have positive ions which occupy the lattice positions. Okay, in metals lattice points are occupied by positive ions, and the released electrons, okay, they exist as free electrons. These free electrons will move to throughout the metal freely. Okay, so just imagine like that. We have a metal. In the metal, the positive ions occupy the lattice position, and the released electrons, okay, they move throughout the metal freely, okay, without much obstruction. Now what will happen? Students, observe carefully. What will happen? When you increase the temperature, suppose if I heat this metal, what will happen? See, with a Bunsen burner, if I heat the metal, what will happen? These ions, positive ions, starts to vibrate. Just imagine like this. They starts to vibrate. Okay, it is called lattice vibration. So on increasing temperature, lattice vibration increases. Right? When temperature increases, as temperature increases, lattice vibration increases. What it will do? This lattice vibration it will obstruct the free movement of electron. Actually, electrons should move freely from this end to that end. Okay, when the electron enters here, yes, current will flow in the circuit. Okay, so from negative terminal to positive terminal, electron has to move. So electron has to move through the metal. But what happens here? The lattice are occupied by positive ions. When you increase the temperature, these lattice ions starts to vibrate. It is called lattice vibration. This lattice vibration obstruct the free movement of electron. Okay, this obstruction, right, causes decrease in the conductivity of the material. So as temperature increases, lattice vibration increases, therefore the conduction, electrical conduction decreases. Electrical conduction decreases in the case of metals. Students, I repeat once again, in metallic conductors, okay, the free electrons are responsible for electrical conduction. Okay, when you connect a metal piece to an external battery source, and if you switch on the battery, from negative terminal electrons are moving, and these electrons enter into the metal. What happens when 10 electrons enter? 10 free electrons starts to move. Just imagine like that. Okay, if the electrons move without any obstruction, yes, you will get good conduction. But what happens is that as the temperature increases, okay, as temperature increases, these metal atoms have positive ions in the lattice. These lattice ions starts to vibrate. Depending upon the temperature, the vibration may be, if the temperature is low, the vibration amplitude is less. But if temperature increases, they vibrate with the larger amplitude. Therefore, this vibration obstruct or prevent the free flow of electrons. Okay, therefore what happens? The conduction of the material will decrease, or conductivity of the material decreases. So in metallic conductor, when temperature increases, conduction decreases. Keep this in mind, very important. Whereas when you come to electrolytic conductor, let me go to electrolytic conductor. What happens is that in the case of electrolytic conductor, I have told you, in the case of electrolytic conductor, ions are responsible. Okay, these ions will migration of ions, right? Ion migration is responsible for the conduction. Okay, why electrolytic conductors conduct current? It is because of migration of ions. Okay, and see, normally these ions migrate, okay, in in the aqueous medium or in the molten state. Okay, the ion migration takes place in the molten state or in aqueous medium or in any other solvent medium. Okay, so when you increase temperature, what will happen, students? See, suppose I'll take some solution. And in this I have ions, positive ion, negative ion, etc., etc. Okay, if I immerse two electrodes, one positive electrode, one negative electrode, that, and if I pass current, what will happen here? Students, observe carefully. This is negative because it is connected to negative terminal of the battery. So this electrode is negative electrode, and this electrode is connected to positive terminal of the battery. So this is positive electrode. Now ions, negative ions will move towards positive electrode, and positive ions will move towards negative electrode. This is the concept. Okay, if ions migrate, then the solution conducts current. Simple. Okay, migration of ions is responsible for the conduction. Now if I heat this solution, what will happen? I'll keep some burner and I'll just heat the solution. Right, on heating, students, listen carefully. On heating, the speed of the movement of ion increases, or mobility increases. Right here, as temperature increases, mobility, okay, mobility of ions increases. Okay, students, observe carefully. In the case of electrolytic conductors, conduction depends on how fast the ion moves. Okay, we are going to discuss all these things as we go along, but let me introduce this point now. As the temperature increases, mobility is nothing but speed. Mobility of ion increases, so ion starts to move faster. Therefore, in the case of electrolytic conductors, as temperature increases, conduction increases. This is the basic difference between metallic conductor and electrolytic conductor. In metallic conductors, electrons are responsible for conduction, whereas in electrolytic conductors, ions are responsible for conduction. Then in metallic conductor, when temperature increases, conduction will decrease, whereas in electrolytic conductor, when temperature increases, conduction increases. Okay, students, is this okay? So now we are going to focus on okay, yeah. So before going to discuss electrolytic conductors, let me first introduce what is meant by an electrolyte. what is meant by an electrolyte. Okay, take down. What is an electrolyte? Electrolyte is a substance which produce or furnish, okay, which furnish ions. Okay, electrolyte is a substance which furnish ions in the molten state, or in dissolved state, Okay, electrolyte is a substance which furnish ions in the molten state or in dissolved state. What is meant by molten state? You take this substance, okay, heats the substance without adding any solvent. Just take the substance, solid substance, heat it strongly, okay, above its melting point. What will happen? The substance will melt and become a liquid. Okay, we call that state as molten state. In molten state, okay, substance will produce ions. Or you take some substance, dissolve in some solvent, water or alcohol, anything. Okay, if the substance produce ions, then that substance is called electrolyte. So electrolyte is a substance which will produce or furnish ions either in the molten state, okay, in the molten state or in the dissolved state. Okay, that is the definition for electrolyte, right? We have many electrolytes. Okay, usually the ionic compounds, not all, most of the ionic compounds, okay, they have ions in the solid state itself. Okay, ionic compounds, they have ions in the solid state itself. Students, observe carefully. You might have heard about this. In ionic compounds, positive ions and negative ions, right, they held together by means of ionic bonds. Correct. So in the solid state itself, these compounds have ions, right? But in the solid state, these ions are tightly held together, so they cannot move. So in solid state, they do not show any conductance. Students, observe carefully. Ionic compounds in solid state, they do not show any conduction. In solid state, they do not show conductance. Why? Because the ions are tightly packed. Okay, what is the reason? The reason is ions are tightly packed in solid state, packed in the solid state. That's the reason. Okay, so ions cannot move, right? Conduction is due to migration of ions, I told you in the beginning, right? In the solid state, in ionic compound, students, observe carefully. In ionic compound, in solid state itself, ions are there, but these ions are tightly held together by means of electrostatic force, so they cannot move freely. They cannot move actually. Therefore, in solid state, okay, ionic compounds are insulators. Note down. In solid state, ionic compounds are insulators. They do not show any conductance. Okay. Whereas if you melt the ionic compound, or if you dissolve the ionic compound in some solvent, what will happen? They produce ions. Okay, they furnish ions, right? So let me write the next page. Students, observe carefully. You take ionic compound in solid state. Okay, in solid state they are insulators, I have told you. In solid states, ionic compounds behave like insulators. They do not show any conduction. Whereas if you melt it, right, in molten state, yes, they furnish free ions. The ions get freed, right? Ions starts moving, right? Ion starts moving. Okay. Similarly, if you dissolve in some solvent, it is called dissolved state. I'll say like that. In dissolved state means the substance is dissolved in some solvent. Okay. Here also ion starts moving. Okay. So in the molten state or in the dissolved state, the ions can move freely. Therefore, the conduction takes place. Okay. So ionic compounds are good conductors in the dissolved state or in the molten state. Okay, students, is this clear? Is this clear? Electrolyte can be an ionic compound. Electrolyte can also be covalent compound. Okay, the main point is they should produce ions, that's all. Ionic compounds, they have already ions in the solid state. They have ions already. But in the solid state, the ions are tightly packed together, so they cannot move. Therefore, in solid state, ionic compounds behave like insulators. But if you melt or if you dissolve in any solvent, then the ions get the ion starts to move freely, so that the material or the solution shows conduction. Whereas if you take some polar compounds, polar covalent compounds, right, like hydrogen chloride. Okay, hydrogen chloride gas, if you see, the molecules are purely covalent. There are no ions. They do not show any conduction. But if you pass this hydrogen chloride gas through water, okay, in aqueous medium, they show conduction. Why? Because the moment you pass this gas through water, they produce ions. Okay, right? Take two. So this is the point that I like to say here is, electrolyte can be an ionic compound, can also be a covalent compound. Right? The main requirement is that they should produce ions. That's all. Right? Next. Okay. Now, students, observe carefully. Electrolyte, I have told you, electrolyte is a substance which produce ions. Okay, electrolyte is a substance which produce ions. Good. In ions, we have two types of ions: cation and anion. Okay, cation and anion. What is cation? Ion carrying positive charge. Okay, what is anion? Ions carrying negative charge. Okay, ions carrying positive charge, ion carrying negative charge. Students, observe carefully. Here in ions, we have monoatomic ions, we also have polyatomic ions. Monoatomic ions and polyatomic ions. What is meant by that? Monoatomic ions, see, sodium ion Na+, potassium ion, fluoride ion, chloride ion, single atom carrying charge. Okay, like that we have plenty of examples. What is polyatomic ions? Polyatomic means group of ions. Okay, say phosphate, PO4 3-. Group of atoms, they carry charge, PO4 3-, SO4 2-. Right? Like that we have plenty of examples. These are all called polyatomic ions. So the ions can be monoatomic or the ions can be polyatomic. Okay, take note. So electrolyte is a substance which produce ions. In ions we have cation and anion. Cations carry positive charge, anions carry negative charge. Okay, and in ions we have monoatomic ions and we also have polyatomic ions. Right? These are all few examples for monatomic ions, and these are few examples for polyatomic ions.
Sir,
Yeah.
sir,
We classify electrolytes into in general electrolytes into two. Okay, we classify electrolytes. We classify electrolytes basically into two: strong electrolytes, and the other one is weak electrolytes. Take two: strong electrolytes, weak electrolytes. What are strong electrolytes, students? In what sense we are saying that some electrolyte is strong, some electrolyte is weak? Okay, this strong weak doesn't mean that the compound is strong, the compound is weak. No, it's not like that. Suppose students observe carefully. Suppose I'll take some amount of water in a beaker. Now I'll put 1000 molecules of some electrolyte. Okay, I'll take 1000 molecules of some electrolyte E. If all the molecules ionizes, if all molecules become ions, right, in solution, we call that type of electrolyte as strong. Here meaning for strong is different, student. Keep this in mind. Don't think that strong means if I put the electrolyte on hand it will cause irritation or it will burn. Not like that. Here strong means if I put 1000 molecules of the electrolyte in water, just for understanding purpose I have taken 1000 here. Okay, 1000, if you put 1000 molecules of electrolyte in water, if all 1000 molecules become ions, immediately become ions, then those electrolytes are called strong electrolyte. Okay, there are plenty of examples available for strong electrolyte. Sodium chloride is a strong electrolyte, potassium chloride, okay, hydrogen chloride, many examples are there. These are all examples for strong electrolyte. They readily undergo ionization. Complete ionization takes place. Okay, strong electrolyte undergoes complete ionization. Complete ionization means if I put 1000 molecules, all 1000 molecules dissociate, become ions. Okay, what are weak electrolytes on the other hand? Weak electrolytes are electrolytes which undergo only partial ionization. Undergoes only partial ionization. Okay, what is the meaning? Suppose if I put 1000 molecules of some electrolyte in water or in any solvent, I'll put 1000 molecules of some electrolyte. Assume that out of 1000 molecules, say for example 20 molecules dissociated. Okay, so 20 molecules dissociated and become ions. Remaining 980 molecules exist as electrolyte. Only 20 molecules dissociated. Remaining 980 molecules exist as electrolyte in the neutral form. We call that type of electrolyte as weak electrolyte because only small number of molecules dissociated. Okay, so we represent, listen, for strong electrolyte and weak electrolyte, listen, students, suppose if we take some electrolyte as strong, AB, assume that AB is an electrolyte. If I say is a strong electrolyte, then it will undergo complete ionization. You will get cation and anion. On the other hand, if I say some electrolyte is weak, say for example I'll take some electrolyte CD, right? This will undergo only partial ionization. So we represent this by this symbol, C plus and D minus. Here this single arrow indicate complete ionization. Here this reversible arrow indicate partial ionization. Okay, whenever strong electrolyte is given, you should write the dissociation of the strong electrolyte with a single headed arrow like this. For weak electrolyte, you should put reversible arrow. Okay, take two. And here you will get what is called equilibrium. Whenever you have a reversible process, a reversible reaction happens, then the reaction will attain equilibrium. Here we don't have any equilibrium, no equilibrium here. No equilibrium. Okay, so keep this in mind. In electrolyte we have strong electrolyte and we have weak electrolyte. Okay, students, let me ask a question. Suppose for weak electrolyte we can give examples like HF. HF is a weak electrolyte. HNO2 nitrous acid is a weak electrolyte. Okay, HCN hydrogen cyanide is a weak electrolyte. Like that we have plenty of examples. These are all examples for weak electrolytes. Okay, now suppose if I take 1000 molecule of sodium chloride, each molecule can produce 2 ions, one cation, one anion. And I will take 1000 molecules of hydrogen cyanide. Students, observe carefully. I will take 1000 molecule of sodium chloride, 1000 molecule of hydrogen cyanide. If I dissolve them in equal amount of water, I will take a beaker with some amount of water. I will take another beaker with same amount of water. If I put 1000 molecule of sodium chloride and 1000 molecule of hydrogen cyanide separately in water, which solution will show high conduction or conductance, electrical conductance? Which one?
NaCl.
Why? What's the
NaCl.
yes, your answer is correct. What's the reason?
Strong electrolyte.
Very good. NaCl is a strong electrolyte, so all 1000 molecule become ion, correct? Okay, when one molecule dissociate, students, when one molecule of sodium chloride dissociate, I will get one sodium ion and one chloride ion. But now I have added 1000 molecules and all 1000 molecule dissociated. So this dissociate, you will get 1000 sodium ion and 1000 chloride ion. So altogether the solution contain 2000 ions. Correct? When one molecule dissociate, you will get 2 ions. So if 1000 molecule dissociate, you will get 2000 ions. Whereas if I take hydrogen cyanide, yes, hydrogen cyanide, if dissociate, you will get H plus ion and Cn minus ion. Yes, if one molecule of HCN dissociate, you will get one H plus ion, one Cn minus ion, no doubt in that. But if you put 1000 molecule in water, not all 1000 molecule dissociate. Okay, say out of 1000 molecule, say for example 20 molecule dissociates. Okay, so I'll get 20 H plus ion and 20 cyanide ion. So we have only 40 ions altogether. Right, remaining 980 molecule exists as undissociated molecule. Okay, so though we have added same number of molecules of strong electrolyte and weak electrolyte, strong electrolyte produce maximum more number of ions. Okay, so conduction will be very, very high in the case of strong electrolyte. So remember, what are the factors affecting conductance? Students, observe carefully. Factors affecting conductance. I am going to define all these things, what is conductance and all. But before that, let me give this point. What are the factors affecting conductance? Number 1, number of ions. First point. As number of ions increases, conductance increases. Conductance is directly proportional to number of ions. Take note, students. As number of ions increases, conductance increases. So why strong electrolyte shows high conductance compared to weak electrolyte? Because strong electrolyte produce maximum number of ions. Okay. Number 2, factors affecting conductance. Mobility of ions. Mobility, here mobility means speed. Okay, mobility of ions. Right, as mobility of ion increases, yes, conductance increases. Remember, if you have a small size ion and large size ion, students, which ion will move faster in solution? Suppose I have a smaller ion and a larger ion. Assume that they carry same charge. Which one move faster in solution?
Small one.
Okay, in general, smaller size ion will move faster. Okay, right? So conductance is inversely proportional to, right, size of the ion. But here, students, keep this in mind. You should see the size of the solvated ions. Okay, very important point. Note down. Solvated ion size you should see. What is the meaning? See, for example, I'll take sodium chloride and I'll take cesium chloride. Students, observe carefully. I'll take 1000 molecule of sodium chloride and I'll take 1000 molecule of cesium chloride, and I'll dissolve this 1000 molecule of sodium chloride in a beaker containing some amount of water. Similarly, I am going to dissolve 1000 molecule of cesium chloride in a beaker containing same amount of water. Okay, I'll put 1000 molecule of sodium chloride here and 1000 molecule of cesium chloride here. Both are strong electrolytes. Students, observe carefully. Sodium chloride, cesium chloride, both are strong electrolyte. Now the question is, do they show same conductance or different conductance? Conductance same or different? So in aqueous medium, okay, if I take lithium chloride and sodium chloride, potassium chloride in aqueous medium, rubidium chloride in aqueous medium, and cesium chloride in aqueous medium. Okay, in aqueous medium, conductance increases from top to bottom. Conductance increases. Why? What's the reason? Listen, if you see the size of the ions alone, lithium ion, sodium ion, potassium ion, right, rubidium ion, cesium ion, if you see the size of only these ions, yes, when you move from top to bottom, size increases. But if you see the size of solvated ion, okay, solvated ion, if you see the size of solvated ion, in this case, if you go from lithium to cesium, lithium, sodium, potassium, rubidium and cesium, right, here as you move down, size decreases. Okay, so it is the cesium chloride solution that shows maximum conductance, okay, among these five. Okay, so conductance increases from top to bottom. Is this clear, student? Is this clear?
Yes, sir.
Okay, so mobility of ions depends on two things. One is size of the solvated ion and temperature. Okay, mobility is inversely proportional to size of the solvated ion. Smaller the solvated ion, higher will be the mobility. Higher is the mobility, higher will be the conductance. Right, and second factor that decides mobility is temperature. Okay, as temperature increases, kinetic energy of the ions increases, the ions move faster. Okay, so mobility is directly proportional to temperature. Right, so as mobility increases, conductance will increase. Simple.